Hey, what's up everyone? And in this video, we're going to take an in-depth look at selection sort. Selection sort is a very simple sorting algorithm that works by breaking a given array into two parts. An unsorted part, which stores all of the unsorted elements, and a sorted part, which stores all of the sorted elements. Each time you scan through the array, you iterate over each element in the unsorted part, find the smallest element, and then swap it with the first element of the unsorted part. You then continue to sort the elements one by one until the entire array is sorted. Let's look at a simple example. Let's say we are given this array and we want to sort it in increasing order. The red line represents the barrier between the unsorted and sorted parts of the array. All of the elements to the right of this line are unsorted, while all of the elements to the left of this line are sorted. However, since we haven't done anything yet, all of the elements are currently unsorted, and they are all to the right of the red line. So, for the first scan, we iterate over each element of the unsorted part of the array, and we find that the smallest element is 1. We then look directly to the right of the red line, and we find that the first element of the unsorted part is 4. So we then simply just swap the two elements, and we now know that 1 is sorted. So we push the red line over one element. And now we just repeat these steps. We iterate over each element of the unsorted part of the array, and we find that the smallest element is 2. We then look directly to the right of the red line, and we find that the first element of the unsorted part is 5. And like before, we simply just swap the two elements, and we now know that 2 is sorted. So we push the red line one element further. Once again, we iterate over each element of the unsorted part, and we find that the smallest element is 3. We then look directly to the right of the red line, and we find that the first element of the unsorted part is 5. Like before, we simply just swap the two elements, and we now know that 3 is sorted, so we push the red line one element further. Once again, we iterate over each element of the unsorted part, and we find that the smallest element is 4. However, we also find that the first element of the unsorted part is 4 as well. So in this case, we don't need to swap any elements, and we know that 4 is in its correct position, so we push the red line one element further. Lastly, since there's only one element remaining in the unsorted part, we know that 5 is the smallest element, and we also know that 5 is the first element of the unsorted part, since there is only one element. So, like with 4, we don't need to swap any elements, and we know that 5 is in its correct place, so we push the red line over one more element, and we now have a completely sorted array. Alright, now that we understand selection sort visually, let's start to look at it programmatically by taking a look at its pseudocode. So here's the pseudocode for the selection sort algorithm. It works in the exact same way as we just visualized. The outer for loop loops through n-1 times, which is one time for each element in the input array. And since each time we loop through the array, one element gets sorted, the ith index also represents the first element of the unsorted part of the array. So, for example, if I equals 2, the first element of the unsorted part is at index 2, or is the third element of the array. Next, we create a min-index variable, and we set it equal to I. The min-index variable will store the index of the smallest element in the unsorted part. So when we initialize it, we assume that the first element of the unsorted part is the smallest element. And then we create an inner for loop to scan through the rest of the unsorted part of the array. And as it iterates over each element, it is checking whether that current element that it's looking at is smaller than the element we currently have stored in min-index. And if it is, we simply just update the min-index variable with the new index of the new smallest element. And then once the inner for loop has completed and all of the unsorted elements have been checked, we know that the index of the smallest element is stored in the min-index variable. And then the last step is to simply swap the first element of the unsorted part, which is at index I, and with the smallest element, which the index of that is stored in min index. And then we just repeat this until the outer for loop has completed, and then we know that the entire array is sorted correctly. Alright, now that we understand selection sort visually, and we've looked at its pseudocode, let's quickly take a look at the time complexity of selection sort. So since we need to iterate over n elements in order to find the smallest element of the unsorted part, and since we need to repeat this process n times in order to guarantee that the entire array is sorted correctly, we know that the time complexity for selection sort is O of n squared. And this is the same for best, worst, and average case. Alright, thank you guys so much for watching this video. If you guys learned something or enjoyed it, please be sure to drop a like and subscribe to my channel, and comment down below if you have any questions. And yeah, I'll see you guys in the next one. Bye.